My name is Joost VandeVondele, and I will be representing the Swiss AI initiative on Alps. I think the slides should show right now. And I want to show three announcements that triggered public interest in Switzerland in the last few years. And the first one is in 2021, when the Swiss National Supercomputer Center, CSCS, announced that they will install Alps, and I will discuss what is Alps. The second one, which I don't have to explain here, is in 2022, just 2 years ago. OpenAI introduced ChatGPT to the world, and I think that is part of the big hype that we're seeing today. And then only 1 year later, the two big federal institutes of technology, ETH Zurich and EPFL, they announced the Swiss AI initiative, and that's the second part that I will present today. So I will talk a little bit about the infrastructure that we are building in Switzerland, and the AI initiative, and how the AI initiative also wants to interact with the private sector. Now, what is CSCS? It's the Swiss National Supercomputer Center that operates a research infrastructure. We developed that infrastructure with the goal of providing high-performance computing and data services to lead to world-class science in Switzerland. And the way we do that is that we built this infrastructure that is very well connected to experiment. For example, we process a large fraction of the data, of a sizable fraction of the data of CERN, the Institute of Particle Physics. We work together with things like light sources at the Paul Scherrer Institute, and we even do the operational forecasts for weather in Switzerland, namely we work together with Meteo Swiss. And all of this is supported by a great network infrastructure. But primarily we are an institution that has to promote science, and so our success, I would say, we measure that by impact in science, number of publications or discoveries made at CSCS. But it's also a research infrastructure, and that is we are open to the world, not just to Switzerland. So scientists of the whole world can come to CSCS with proposals for excellent science, and they can make use of the resources. And about 30% of our resources are actually distributed worldwide. And I think that's very good for Swiss scientists because they are presented with a competitive environment where they have to excel to get their part of the share. And at the same time, of course, we promote an exchange between scientists because science is not a local, it's a global enterprise, and that's very important. Now, I also want to point out that we don't have just infrastructure in Switzerland, and in fact, we share infrastructure with Poland as one of the countries in the LUMI collaboration that was already mentioned. So Switzerland, as well as Poland, has a share in a fairly large supercomputer that is located in Kajaani in Finland. And so we are actually collaborating in the field of HPC, and I think this collaboration is very important. We in Switzerland say this supercomputer in Finland is built on a blueprint developed in Switzerland, and I will come back to that. But we want to contribute to this whole international endeavor of creating great infrastructure for science and for the private sector. Now, why do we have some credentials in this? We have been investing in GPU computing, and GPU computing is really what has kind of enabled this AI revolution in the last few years. We've been investing in this in Switzerland since about 2011, when we deployed the first supercomputer based on GPUs as one of the first players worldwide. And in 2017, we deployed what was our flagship infrastructure, which we named after a mountain, Pitt Stained. That was at that time the largest, but also the greenest supercomputer in Europe. And for this computer, we were the launch customer, so the first large customer of NVIDIA to deploy a certain type of GPUs, the P100. And now this year, we have been fortunate to inaugurate the new part of the infrastructure, that the successor of this machine, and this is named Alps, and that's the first part of my title. It's probably, and we're waiting, 2024 is not yet over, the largest open research infrastructure in Switzerland, in Europe again. So it's a very large supercomputer. It's using one of the greenest technologies, and also this computer is in Switzerland. It's powered by hydropower, so has a low CO2 footprint. And we are again the launch customer together with NVIDIA for the latest generation of GPUs. Now, the size of this, we measure that in the number of GPUs. We have about 10,000 GPUs in the supercomputer. For an open research infrastructure, this is very large. But this is still small compared to the largest supercomputers these days that are owned by private companies. We might have seen the announcements by Tesla or the large announcements by Microsoft. The sizes there are at least a factor of 10 larger than what we field academically. Now, what I also show is the power used by these systems. And this is a very large infrastructure, very capable. And it uses, and I recycled the slide, the power of about 2 trains. Because usually in Switzerland, I travel by train. Now, to this meeting, I came by a plane. And it's actually only a fraction of the power that a single airplane actually needs to carry me from Zurich to here, Poland. And I think that's interesting to see that perspective. Now, why did I emphasize so much this infrastructure that we deliver? Because I think modern AI is very tightly linked to the capabilities to train these large networks. And the reason for this is shown in this left graph. It's showing that the accuracy of the models is directly proportional or limited by the computational power that you deliver. It's these famous power law, scaling laws that basically relate, in this case, compute and quality. And because quality is very important in this race, you see that the large models that are being developed are increasingly hungry for compute power. And that's shown in the right-hand graph, where you see the amount of compute needed for some of the modern AI models. And what you see there is a staggering rate in their need for compute. Every year, the need is increasing fourfold. That means that in just 5 years from now, if this prediction holds, the need will be 1,000-fold larger than it is today. And so even though we can be proud to have a good infrastructure today, in just 5 years from now, this will be very small compared to what is possibly needed. Of course, we hope that science and innovation will lead to models that are much more power-friendly or compute-friendly in the future, but we have to see where this journey goes to. Now let me come to the Swiss AI initiative. So one thing we want to do, in addition to the more traditional computational science and engineering, is support AI in Switzerland. And to do this, the 2 schools have announced the Swiss AI initiative that has as the goal to develop the capabilities, the know-how, and the talent to be able to produce Gen AI foundational models that are aligned with Swiss values. It's something else we see. We all use the chatbots that are around. They are developed in California. They might be aligned much more with US values than they actually are with some of the European or the Swiss values. And then the goal is to make these models available to Swiss actors, but also, of course, globally. The guiding principles, and I think this is well aligned with Swiss values, is to build that with trust, openness, and collaboration, going through the traditional cycle of pre-training, alignment, red teaming, and deployment. So that is what is, in very broad lines being planned. Why is this important, you say? Because there are open models, and we know, for example, Meta has released the Llama herd of models, but we also know that it's just open weights. We don't quite know what went into the training of these models, and it might mean that even in Europe, as soon as this AI Act is being instated, that you cannot just use such an open model because you cannot really say what data went into the Llama model. And so there is a need to try and match it. And I just highlighted here in the EU Act, and I will follow Magnus' advice and have it summarized and read to me because it's 500 pages. You see the requirements on data. And on the right-hand side, you see the Llama paper. And you also see that the whole description of the data is essentially one sentence. And that will probably not hold to the requirements of the EU AI Act. Now, has Switzerland anything to say? I think the statement was made before, the US and China are leading here. And I wanted to show this graph, which shows the number of publications per capita in various countries. And you see that actually Switzerland on this graph is actually doing much better than the US or China in the number of publications published. And I think we can attribute that to the great educational system in Switzerland that has multiple levels. We have mentioned the Federal Institutes of Technology a couple of times, but we have great cantonal universities. And I think, in particular for AI, it's also very important to mention that we have the universities of applied sciences. These are universities that have, the capability and the tradition to work together with industries and translate some of the knowledge. And especially for AI, which is a very applied technology, or if has a lot of practical applications, this might be key to make a big impact. And so we try to unite all these players in this one initiative. Now, I want to make one point clear. If you look at data, don't divide by small numbers, because the Vatican here apparently has the highest publication rate per capita. It also wants to make sure that Switzerland is also a small country. That means that seen in the big pie, our rate of publications is actually small. Yeah? So we have to of course acknowledge that a lot of the progress is being made elsewhere. Now the Swiss AI initiative, how is it structured? It's a fairly large initiative. We try to bring together all these PIs in Switzerland that are doing research on AI, and it's about 70 PIs, about 500 PhD students. We've organized that in 11 areas. 6 of the areas, they look at what we call horizontal capabilities, the capability to train models, the capability to bring multimodal models ready, or to do red teaming and so on. And then 5 areas of application. And we have models that will be specifically trained for the sciences at large, maybe chemistry. We have models that go towards education, models that focus on health, models that look at sustainability, and models, sorry, I have to check here, that will look at the health sector. One of the early successes is a model that we call Meditron. It's a large language model trained to answer questions in the medical domain. And true to the statement before, it's trained on open data. For example, abstracts of papers in this domain, or manuals, guides that doctors use to actually work in practice. And it's fairly interesting to see, despite the fact that this is still a relatively small model, it's one of the best, or it is at the point of publication, the best open model. And it's actually quite competitive with some of the commercial models that also are aiming at the same field of medics. And it's quite nice to see. This model has been already deployed in the field. So one of the reasons to develop this model is to actually support developing countries or resource-poor countries. It's being developed there. It has been pitched to the World Health Organization, the Bill Gates Foundation, and is getting support to actually deliver at a very short time scale in practice and try to improve the life of people that might benefit from this. Last few slides. One example is what we call the sustainability vertical, trying to improve our capabilities to predict climate, or at a shorter time scale, predict weather. This is something where I personally see there will be a lot of progress being made. It's very valuable to society. And it's also a field where a lot of data is available. Observational data, satellite data of the last 30 years or so is all there. And we can also integrate that very well with simulations, traditional science-based simulations that run at the center. We can have very high quality predictions with the infrastructure we have, and at the same time use that data to train foundational models that can predict more accurately whether in a short time. And that's already happening today. So we see that foundational models today trained on weather data are very competitive, to say the least, with traditional physics-based models for short-term predictions, a few days. That domain of weather and climate will also help us to develop our infrastructure, the capability to deal with petabytes of data that might come in at a daily rate. The second example would be the vertical of health. It's clear that AI can help to analyze medical data in various ways, analyze images to be able to segment an image or see maybe unhealthy cells, be able to deal with intensive care unit data, time signals, and maybe predict if a patient will need more attention in the night to come. And this will help us, and this is really a challenge for an academic data center, to deal with data that has, is of sensitive nature and has personally identifiable information. And I think that is something where we as an academic center have to learn a lot, and also actually could learn a lot from companies that have that experience on how to deal with data. Final 2 slides. Swiss AI is actively looking for public-private partnership, would like to integrate some of the larger companies in this initiative, basically to give these companies the opportunity to learn, basically work together with researchers in such an initiative, be actually actively engaged in some of the research, and at the same time enable these companies, if they are experienced enough, to generate IP, to generate models that might have a business value. I have to hurry a bit up. There will be 3 levels where we see basically a membership level. This is people that want to listen in. They just want to be part of seminars. They want maybe to show what they are doing. There will be a contributor level where people actually have researchers, company researchers that participate in the open science projects that are going on. And there's a strategic level in which companies will actually be able to do IP generating research that is separate. And all of this will, of course, be facilitated by the infrastructure we develop. With this, I would like to conclude. We have been able to field one of the largest AI-capable supercomputers this year. This infrastructure is key. No infrastructure, no modern AI. And we have started an AI initiative that unites the talent in Switzerland and also will generate more people that are capable to deal with this technology, know the latest state of machine learning. And then finally, we have a model, or we're in the process to develop a model that allows for these public-private partnership. Thank you.